Okay, ladies and gentlemen, let's talk about triangle side inequalities. Now, obviously, a triangle has to have three sides. I have three sides here in front of me. But what we're going to talk about is when I have three known sides, that's fine. I can make the triangle match. But if I only know two sides of a triangle, the question becomes, what is the longest and shortest that that third side could be? Now, in this case, let's take a measurement here. This one is 4¼ inches. So I have one side that is 4¼ okay, and that's inches. I have another side that looks like 5½ So I have 5½ inches. So the question becomes, what's the longest possible third side that I could have? Longest possible third side that I could have? Well, that would be as if these two sides were, instead of being at an angle, were absolutely as straight out as they could be. That would make the third side as absolutely long as possible. So let's measure it. If that's the case, I come up with 9¾ 9¾ So the longest side is 9¾ All right, so now that would be the longest side, although it's not really much of a triangle at this point. For it to really be a triangle, it has to be at an angle. So even if that angle is not very big at all, even if it's not very big, that means that it's got to be less than 9¾ The longest has to be x is less than 9¾ Otherwise, it's not really a triangle. So if that's the longest, let's see what the shortest would be. Well, the shortest a side could be is if I bring these way together, bring them super together. The shortest it could be would be if those two were almost touching each other. So the shortest it could be would actually be, I see 1¼ maybe 1¼ strong, but 1¼ So the shortest would be 1¼ but although, again, same problem, if they literally are touching, it's not really a triangle, so I'd have to move it off just a little bit, which would mean it gets a little longer than 1¼ automatically. So x has to be greater than 1¼ So whether I have a super duper long side like this, or whether I have a super duper short side, as short as I could make it like this, it doesn't frankly matter. Now, we should be able to come up with some reasonable things. The key to this is that any two sides of a triangle, any two sides, must be bigger than a third side. So any two sides must add to greater than the third side. Okay? So there we go. Any two sides must add to be greater than a third side. To do that, that means if I take side A plus side B, it's got to be greater than side C. Side B plus side C has to be greater than side A, and side C plus A has to be greater than side B. Now, in practice, that means what we could do is if we call this one A and we call this one B, A plus B is going to give us the longest. And A minus B, absolute value, is going to give us the shortest. Now let's talk about why absolute value. because if I take 5.5 minus 4.25, that gives me 1.25. But if I take 4.25 minus 5.25, that gives me negative 1.25. So since we can't have negative distance, we simply take the absolute value. Now, we're never worried about absolute value on A plus B, because in A plus B, it's two positive sides, and you're always going to get a third positive number. So the longest side is always found by adding, the shortest side is always found by subtracting and making sure you have the absolute value. You'll notice that I proved it with a ruler, but really we could have just said 4.25 plus 5.5 equals 9.75. So the longest the third side could be is something less than that. And that the shortest would be take one minus the other, 1.25, and that would be the absolute shortest. So if I give you some sides, so for example, 1, and I say side A equals 4 and side B equals 17, side C could be somewhere between 4 plus 17 and 4 minus 17 absolute value. Here we go. So we have 21 could be the longest side, but again, it can't really equal 21. It's going to have to be less than 21 for it to be a triangle. And it's going to have to be greater than the absolute value of negative 13, which is 13. So it has to be bigger than 13 and smaller than 21. And it's nothing more than adding two sides or subtracting two sides. So there's nothing too terribly complex about that. Let's go ahead and take a look, though, at one other type of example. If we have, like number 20 in the book, and we have x plus 5, 2x plus 22, and 5x minus 7. If I want to find x, well, I know that any two sides, so this one and this one, have to add up to be greater than this. So if I say x plus 5 plus 2x plus 22, that's going to have to be greater than 5x minus 7. So those two added up have to be greater than the third side. That also means that the absolute value, and we'll take 2x plus 22 minus x plus 5, is also going to have to be less than 5x minus 7. So let's take a look there. In this case, say these two have to be bigger than the third side, and this side has to be bigger than the two subtracted. So let's put them together. I come up with 3x plus 27 is greater than 5x minus 7. Subtract 20, subtract 20, subtract 5x, negative 2x is greater than, negative 27, and I come up with negative 34. Divide both sides by negative 2. Now, of course, anytime you divide by a negative, you must switch the sign. So x has to be less than 17. X has to be less than 17. But now let's deal with the other one. I have 2x minus. Now, I do need to be very careful because I took one side minus the other side. It needs to be in parentheses. So 2x plus 22 minus x minus 5 less than 5x minus 7, because I got to give away the negative. And so we come up with x plus 17 is less than 5x minus 7. If I add 7 to both sides, minus x, I come up with 24 is less than 4x. Now, if I divide by 4, x has to be greater than 6. So x greater than 6. So if I'm looking for what can x be, I took any two sides and added them to make them greater than the third one, and the third one has to be bigger than the subtraction of the two sides. I solved each piece, so my answer would be 6 less than x less than 17. That's how we would take care of it there. All right, so we'll go from there.